Hello, my name is Amit Lieberman. I am the director of the core and platform team in Firefly. Firefly is a cloud asset management platform. And prior to Firefly, I managed a SaaS platform and SRE in Aqua Security. And today we're going to have a session discussion about 4 reasons why our infrastructure as code strategies fail and a couple of tips about how to do it right. So, direct dilemma. Talking about infrastructure as code, this solution comes to give us more order and governance about what we deploy, but it introduced a lot of issues, frustration, complexity, errors, and why? Why is something that's supposed to make our life easier sometimes makes it harder? So we're going to focus here about 4 reasons why is it complicated. I think we can even go about tens or hundreds of reasons, but focus here in 4 major ones. One of them is a lack of a clear strategy. Second one is ignoring the human factor, always an important thing to take into consideration. Neglecting security. Security is very important in our day-to-day work, and overlooking continuous improvement. If you have any questions, you can write them in the comments, and I'll leave 10 minutes, 5 to 10 minutes at the end to answer them. So let's start with reason number one. So reason number one, lack of clear strategy. When moving our infrastructure to be managed with infrastructure as code, we need planning. As we do with any service that we develop, we need to think about what are our goals. Do we want to deploy this, for example, the prod environment, multiple environment? Do we want to have different regions for environment? We need to think about, for example, where do we manage our state? Do we want to do it by ourselves? Do we want to use some kind of provider like N0 or Terraform Cloud? We need to think about how we're going to manage and what is going to be our strategy. Another thing related to lack of strategy is inconsistent in tool choices. I'm talking about different companies, you can have a lot of departments. One department can use, for example, CloudFormation. Another one can go and choose Terraform. And when everything tries to join together, it can make a mess. We need to think also, do we want to use imperative or declarative tools? Imperative relates to specifying the exact steps and commands needed to achieve a desired goal. For example, imperative tools include Chef, Puppet, Ansible. When talking about declarative tools focus on defining the desired end state that we want to reach without specifying the exact steps together. And looking at declarative tools, we have Terraform, CloudFormation, ARM, Pulumi, and even Kubernetes is a declarative tool. We also need to think about what do we do with the existing resources. When we move to infrastructure as code, we have resources running on the cloud. They might have been created with infrastructure as code tool. They might have been created with ClickOps. We need to think about the strategy. Do we want to keep them? Do we want to reverse IaC them? Do we want to delete them and create them from scratch? So these are the strategies that some of the strategies we need to focus on, how we're going to manage it, how we're going to, what is the skill set that we have in order to choose the correct tool. Reason number 2, ignoring the human factor. Human factor is always important. For example, skill gaps. We can choose a tool, for example, Terraform CDK, but the skill set in our teams is not in the level to use the CDK. We can have issues that happens a lot. We see it in different companies. We have silos. We can have a group or a team that is very efficient in using a specific tool, but another group is not. And the team that is very efficient doesn't want to slow down and start teaching the other team. They want to move fast. And then this creates silos in different teams. This requires us as managers to understand and train our teams, so we have better skill set. Resistance to change. Sometimes people don't want to learn. It's easy to use ClickOps. They want to go to the AWS console or GCP console and create it manually. So resistance to change is something that we always face with different teams. Ineffective collaboration is also something, cross-department alignment. We can have, for example, a department that is very efficient, works with modules, has a very efficient change management, but doesn't play well with others. So again, human factors is super important, and we need to be realistic about the skill level in each team and know how to improve the skill sets of the team members that are not on the same level. Reason number 3, neglecting security. Security is super important. When we're talking about infrastructure as code tools, true or false in the infrastructure that we are deploying can expose us to attacks, can open, for example, a resource, let's take into example an S3 bucket, to be public. So we need to make sure that security is always at the top priority in everything that we do. It's not only infrastructure as code, it's when building services. Security should always be in the mindset, and there's a lot of tools today. I'm going to give a couple of examples later that can help us in making sure that we are secure and compliant. And so again, one of the issues is not implementing infrastructure as code security scanning in our CI/CD, having specific policies, gates, specifying which policies we want to comply for our infrastructure. Neglecting security can expose us to vulnerability. Again, we can have public, we can expose customer data, we can expose security keys, and this is something that we always need to have in mind when working on our infrastructure as code strategy. Reason number 4, overlooking continuous improvement. Continuous improvement is basically like a company culture. Understand that setting up our tooling, setting up our capability doesn't stop there. We always need to improve. We need to understand how to monitor our KPIs, and how do we understand that we are improving. Day 2 tasks, for example, documentation, something that is supposed to be very simple documentation, but especially when we're talking about big teams with a lot of people, there's a lot of change in the people join and live in the company. Documentation makes it easier to onboard, understand, not having like knowledge in the mind of one of the team members, and then when he leaves, you have to reverse engineer and understand everything. So documentation is super important, making it easy, and part of our delivery needs to be documentation, even for infrastructure as code. Another good example is recovery. We need to change, okay, what happens if there's an issue and we want to revert? Where do we keep our state files? Do we know how to restore? Do we train in restoring our infrastructure? Lack of modularity and reusability can code duplication. We can have, for example, a specific infrastructure registry inside of a code, and then we copy it to another registry, to another repository, and duplicate the code. And then when we want to, for example, do some changes in one place, we don't always do it in the other place. So we need to make sure that we're very modular and our code is reusable. We don't want to have a lot of duplication. We want to have one centralized place where we do the change and everybody can come and take this code and reuse it. Drift is very important when talking about infrastructure as code. Drift happens when we have a change with what we deployed to what is actually running in our, for example, cloud. If we take AWS, for example, and we have a deployment that consists of, let's say, an EKS, VPC, S3, or anything else, and we need to do some kind of change. We don't want to spend time doing it. I don't know, where there's like some kind of emergency, in the SRE DevOps platform, we always have emergencies. So we log into the Cloud Console and do a manual change. This causes drift. Drift is a very big issue because if we have drift in one place, it's very hard for us to scale. For example, we have an environment, and for GDPR requirements, we need to deploy it in another region. If we do a change in one region manually, and we don't have any way to understand that we have drift there, it can cause inconsistency between the environments. So overlooking drift is a key issue that exists for many companies for issues with implementing infrastructure as code. I'm going to go a little bit here about do's and don't do's in implementing infrastructure as code. So don't bypass the IaC pipeline. Again, very easy to go into the AWS console and just press checkbox, but we are bypassing everything. We're bypassing our security checks. We're bypassing our testing if we have doing our deployment pipeline, and we need to make sure that we follow the pipeline and the strategy that we defined. What do we want to do? We want to monitor for infrastructure drifts. So again, drift is what happens when your state and your infrastructure differs from the way that it's configured. And there are different tools to monitor drifts and get notifications whenever a drift happens. In the below example here, you can see how in Firefly we monitor our own infrastructure with Firefly and identifying drift. We get an alert. There's a difference between what we see in the configuration in the cloud compared to the desired configuration that we have in our state file. And then we can raise a PR and align those the state file to what's running in our cloud. don't. We need to treat our infrastructure as code the same as we do for all of our services. A lot of times we want to run fast with our infrastructure, with our IaC, and we skip basic things that we'll never do with our other services. For example, testing, running the testing on a dev environment, and again, having the same process of code review, different security gate, to understand exactly that the quality matches what we defined in our strategy. And so again, we need to treat our infrastructure exactly the same way as we treat our other services. Here, for example, on the right, you can see this is a part of the Firefly whenever we run, for example, an infrastructure, we run Terraform here, and we want to understand different policies. We have different policies that are related to security. We can define, for example, that we stop if there is a critical or high security violations in our infrastructure. We can define different policies for cost. For example, a lot of times when people play with infrastructure or start using it, there's no understanding of how much it costs. You can take some kind of, let's say, infrastructure example from GitHub that will result in building like a very expensive stack. And the way that that is advised to work around it is add a policy that knows how to stop you and give you an indication of the cost of what you are creating. What do we want to do? We want to use modules. Modules are typically stored in a version control, in Git, for example, and it provides accuracy and basically a template that everybody can use instead of writing everything from scratch. Create basically a reusable module with different variables to manage the difference between the environments. So we have separate environment without duplicate code, but we can control different variables. So here in the example that we see here, we have basically the root folder. Inside of it, we have our main variables and TF vars. And inside of it, we have a module, like a child module. It can be, for example, of an environment with the main and variable file. And we can control in the Terraform TF vars the way the different variable compared to the environment. Let's take an example that we have an environment for pod and for dev. So for pod, we want to specify, let's say, multi-AZ, and there are different requirements that we need for pod environments. We want to have, let's say, a few availability zone. We want to have like bigger instances for infrastructure. And for the dev environment, we want to have something minimal. We don't want to pay the same price as we pay for the production environment for the dev environment. So we can create a different Terraform TF vars file to control the resource type and sizing that is going to be created from our module. But it's one centralized module. We don't duplicate the module for the pod and the dev or for each environment. We just need to create one Terraform TF vars, and whenever running the Terraform command, then direct it to the TF vars that we require for the environment. Consistent is always important. We want to make sure that we have a style, keeping things consistent. It makes it easier for everyone. Tagging policy, super important when implementing or writing our infrastructure as code, because tagging then connects to different services, cost, There is something called cost allocation tags in AWS, for example. These are tags that you can see in the Cost Explorer, and whenever there's a tagging convention, we can know who is the owner of the service. A lot of times in the past, I've had issues where we have some kind of account, and inside of it we have a lot of resources that we don't know who created them. Can we delete them? Can't we delete them? And having tagging or tagging policy and enforcing that tagging policy enables to identify the service owner, then mapping it to the cost of the service. So tagging very important in everything that we do. Naming convention, also something that looks very, very simple, but naming convention can make it very easy for us when deploying an environment. Here I gave an example of using a TF-var file. So let's say you have a module and we want to use different TF-var file for different environment. So using a naming convention, let's say here we have the region, if it's dev, and then TF-var. So according to the naming convention, we can deploy different environments. So small things in naming convention are also very important for us. Terraform registry modules to use or create. There's a lot of public modules that we want to create. Sometimes we want to do it in-house. In-house we want to do whenever we have, for example, specific security requirement or any custom requirement that we don't want to use like the public modules. So it's always something we need to think, do we want to build it by ourselves, or do we want to use a public one? Just in general, a summary of what modules are basically about organizing and reusing configuration codes. There's also a different term in Terraform, providers, where providers are enabling Terraform to interact with external APIs. So modules are very flexible. We can build them ourselves or use public ones. Branching and deployment strategy, the same as we do with other services. How do we want to do it? We want to do it with main as our production. How do we deploy? Do we want to have a pipeline we would deploy in staging environment, run tests, and then promote it to production environment? So we need to think about those things also when building our infrastructure strategy and how do we want to manage it. State and bucket location is also important. Wherever we keep our state file, we need to make sure that, for example, if we save our state files in AWS S3, the way that the structure of S3 is built is that it's not really like a folder structure. It's more of a path. So even that you do see folders, it's actually one path. So you can't lock multiple files in the same S3 bucket. So when working with AWS and keeping the state files in S3, we need to lock in DynamoDB. So maybe we can choose here to, for example, save our state files in GCP. In GCP, we can save, we can lock on a folder and subfolder level in the same bucket. So again, understanding where do we want to manage a state file, enable versioning so we can revert. There's an option even to choose some kind of provider like Terraform Cloud or N0 to manage our state file. So another thing that we need to take into consideration is where do we want to keep our state files. We need to understand our IaC coverage. We need to understand what is the percentage of our infrastructure that is codified. Codified, here we see an example of the way that we display it in Firefly, how much percent of our of what's running in the cloud is the same as we have in our stage files. So codified, that means that we are aligned. Drifted, that means that we have basically there's a change. We do have the resource in the cloud. We do have the resources. We do have the stage file, but there's a mismatch between them. Looking at managed, that means that we do have we are not managing it by code. And here we see also ghost, that means that we do have a state file, but we don't have anything that's running. We we always need to think about the KPIs. How do we monitor progress? And having these statistics about codified, drifted, and managed in code allows us to understand if we are improving in our infrastructure as code journey. Or so these are again KPIs that we need to adapt whenever we want to implement infrastructure as code. So again, the main takeaways here that we want to see, that I want to emphasize, is use reusable module to manage the difference between environment. Test your infrastructure as code using automated pipeline testing, dev environment, understanding how to promote it, and again treating the infrastructure as code exactly as the application code. Tracking your infrastructure coverage. Understand again how much of my cloud is codified, how much is not. Am I improving? What do I need to do in order to improve my coverage? It's a very simple KPI to monitor, and accelerate IaC adoption. Again, on managed resources, we want everything to be managed. Whenever our entire infrastructure is managed, it's very easy for us to create another environment, to, for example, create dev environment. Say we have a production environment, we want to create like smaller environments for developers. So we need to make sure that everything that we have is managed. It allows us a lot of flexibility. We want to refactor different services. It's getting control of the cloud chaos that I'm sure everybody is familiar with. And we are in the questions. So please write your questions and I will answer. Okay, so I have a question here. Would you please talk more about implementing cross tagging and best practice? Yes, okay. So cross tagging, whenever I'll give you an example here with AWS. In AWS, we have something called cross location tags. It's done on the organization level, and whenever we define a cross location tag, it's basically something we can group by in the Cost Explorer. So having, for example, a cost allocation tag called environment, service, owner, or anything like that can give us exact cost and ability to group according to to this tag and get different cost estimation. So we need to make sure that we tag everything. There's also the capability in all the cloud providers to enforce using tags that if you try to deploy any resource without a tag that's defined in the policy, then deployment is blocked. So again, having something very simple, I always like to have a tag for all the services called service, called environment, and owner. So these are like the three tags that I always like to have, and also enforces again that we don't deploy if those tags don't exist. After that, when we need to start calculating the cost per service per region, then we can do it according to those tags. We have another question here. Beyond the cloud provider documentation, are there other resources to implement tagging policy? Yes, there's different automation that can be done again on the cloud itself, adding tagging, and also there's different policies, and something that we always also use in Firefly, where we can enforce tags. For example, if you don't have any tags, a specific tag that we defined in a policy, then you cannot deploy, or even add some kind of automatic tagging for resources that don't have those kind of tags. So can be done by any script or tools such as Firefly. I have another question here. Which IaC provider do you recommend? I think it depends on what works best for you. I always like choosing something that has a lot of production experience. Basically, all these IaC providers, Terraform, Pulumi, everything they're just wrappers for the cloud APIs. So I always prefer choosing something that has a very large community, a lot of production experience, and less of going with new and say less experienced tools. The platform DevOps SRE, we always like to. There's always something new. You have Pulumi, you have Crossplane. There's a lot of things that are good and interesting, but I want to have everything stable, so I like to choose the tool that is more stable. Okay, so if there's no other questions, I just want to thank everybody for joining. And thank you and have a good day.